Greetings, everybody. So I'd like to take a moment to show you how to solve this problem, which I'm finding on our assignment on my math lab. And the question goes like this. It says, use the graph that's given over here to draw the inverse function. Okay? And it's easy for me to tell you what that is. All that the inverse function does is switch the x's and y's from the original function. So I've got an original function right here. The inverse of that would just switch the x's and y's. That's always true, okay? I'd like to show you that in another context, though. Give a slightly different example real quick. So it turns out these two functions are inverses of each other. Okay, and right now I don't want you to worry about where I got these or how I know that they're inverses. Let's put that aside. I'll use the notation like this. F of x is our symbol for the original function. So I might read this as the original function is 2x plus 1. And f with a superscript -1. That -1 looks like an exponent. It's not an exponent though. That's just a symbol for the inverse function. So I'd read this as the inverse function is x take away 1 all divided by 2. Now, I have just told you what it means to be the inverse function and what the difference is between some original known function and the inverse. It just means the x's and y's are switched. I'll give you an example. Just for the sake of example, I'm going to take the original function, I'm going to plug in 2 for x. And if I do that, I get 5 for y. So I can say that with the function notation right here, or I can write an ordered pair. Remember, in an ordered pair, the x goes first, you get a comma, and the y goes second. So however you look at it, you plug in 2 for x, you get 5 for y. Now, if that really is the inverse, what needs to happen? Well, the x and the y needs to be switched. So what that means is if I plug in 5 for x into this one, I get 2 for y, and I do, okay? So that's how it should work, whether your function is given with a formula or a graph or no matter what. The end result is that the x's and y's are switched between some original function and the inverse. So let's use that and try to solve this one. So I look over here at this graph and I see that I can identify some of the points. Like this point right here is 0 for x and 6 for y. And this point is 1 for x, 9 for y. And this point is -2 for x, 0 for y. So all the inverse would do is switch that. It would switch the x's and the y's for each point. So let me go ahead and draw what that would look like. So first of all, I need to use this graphing tool. I need to choose what kind of shape my ultimate graph is going to be. And the inverse of a line is also a line. So I'm going to select line, okay? And I just have to plot switch the x's and y's. There's 3 points for me to choose from here and switch the x's and y's. I only think I'm going to need 2. So this one was -2 for x, 0 for y. So I want instead 0 for x, -2 for y. There it is. And see how the line's already taken shape? So I just need to pick one more. Okay. So see that one up there? That was 0 for x and 6 for y. So now I'm going to want 6 for x and 0 for y, which is that one right there. Okay, so I can double check those points if I need to, but that's it. I took this one right here, I switched the x and the y, and I took that one and switched the x and the y. I could have used this one too, but I didn't have to, so I'm not worried about it. So I'll save it, okay, and I'll check it, and of course it'll be right. Okay. So that's a kind of an introduction, like something real basic about what an inverse function is. No matter how it's given to you, then you just know that in the end, it just means the x's and the y's are switched. That's really all functions are to start with. You have an x, you put it into the function, or you look at the graph, you do whatever it does, and you get a y. The inverse function is no exception. It's got x's, it's got y's. You plug the x in, you get the y out, no matter how it's given to you. The only difference is they're going to be switched.